Just an introduction. My name is Tejas. That's pronounced like contagious. Easy way, hopefully, I'm not contagious, by the way. Don't you need to cover your mouth. Over the past, many years, over 10 years, easily, I've had the privilege of working at a number of different places, either in some type of consulting fashion or as an employee. And I really love the ecosystem. I love the companies represented here. And working at all these different places, you learn a thing or two. And I'm here to talk to you about that today. Okay. Specifically, we're going to talk about React server components. How many of you know React server components? Okay, how many of you use React server components in production? Okay, this is like 2 people. Today what we're going to do is we're going to dive into the mechanism by which server components work. If you maybe have a crude, like top contour understanding of server components, today you'll understand them deeply. You'll understand what actually happens, how they execute on the server, and what they send to the client side. We'll also look at how the client side then picks it up, and really how we unlock new use cases when both the server and the client speak React. Okay? We won't cover a number of things just because 40 minutes isn't enough time. We won't talk about the basics of React. I'm going to assume that you know that JSX, the virtual DOM, is just a bunch of JavaScript objects. A React tree of elements is just literally JavaScript objects. I'm going to assume you know that. I'm going to assume, we're not going to have time to cover things like use client and how interactivity works with server components because, again, 40 minutes is quite short. And we're not going to cover server actions because they became stable yesterday. And spoiler alert, they're not stable. Believe me, I tried them as Guillermo was talking. As far as I know, cut that from the video maybe. But anyway, let's get in. That's all the slides I have. We're going to spend some time writing code. Keep in mind, I have been writing code since I was 8 years old, so hopefully this proves that I know how. But what we're going to do is look at a little demo. So I made a site that shows you a bunch of dogs. Dog people here? Yes? Okay, good, most of you. Yeah, I love dogs. My favorite breed is, I really like the Shiba Inu, actually, the Doge. So Shiba. So you can click on your favorite dog breed, and you get adorable. And you get a random picture every time. So if I go click Shiba again, it's beautiful. Couple of things. This page is entirely server-side, client-side rendered. So it's using Vite. And you just ship a JavaScript bundle. Without JavaScript, the page doesn't exist. Okay, lots of drawbacks. So if we look at the markup, the source, this is the source. There's nothing. It's just like JavaScript. This is problematic for a number of reasons. Search engines just don't understand this for the most part. Also, any site that consumes the static markup, you're not going to see. Moreover, your time to first meaningful anything is just not there because your browser has to download JavaScript, parse JavaScript, execute JavaScript until something happens. And I guess this is best illustrated by if I come here and if I open the console, and what I'll do is I'll just disable JavaScript, okay? And now my site just doesn't exist. That's a huge problem, obviously. What we'll do is we'll fix this by actually implementing server rendering, so we understand that a little bit, and then we'll do so with server components, so we understand that as well. Let's get into it. So this is the code base. Let's walk through it. Actually, let me go enable JavaScript just to show you side-by-sides of things. Okay, so let's go this side, let's go this side, and let's look at the project. We have the index route, which, if you know the basics of React, this shouldn't be surprising. We hydrate the root of the app into the document, and we have a layout with a background color. Background color should be, okay, you can see that. And we have a very basic router. If the path name is list, show list. If it's literally anything else, show detail. It's a very naive router, but it works, okay? What is the list? The list is a list of dog breeds, and we're doing some really nasty stuff in here. We're fetching in use effect, and when the promise resolves, we set state here. This is really problematic. If you're doing this, you shouldn't, because you want to fetch data as early as possible. This is fetching data as late as possible. Like you're waiting for React to render, you're waiting for React to be ready, then in use effect you fetch, which takes some time from the network, and then you set state, which takes some time from the CPU. This is like the worst possible way to fetch it. Maybe not the worst possible way to fetch it. I've seen worse, but it's definitely not an ideal way to fetch data in React. Okay, but this is representative of most, unfortunately, React apps today. So what's happening here? We fetch some data, and then if we compare markup, we have welcome to my dog site and an H1. We have a P with a paragraph, and we have a UL with a list of dog breeds. So this is straightforward. This is most React apps kind of look like this. The detail page is similar. Let's start by server rendering, okay? And to server render, what we need is a server. We have a file server.tsx, but it's empty. Press Command I to ask Copilot to do something. Let's try. Write me a React server renderer. I've never done this before. I just saw this. If this takes too long, I'm going to abandon because we have, okay, wow, not bad. It shouldn't have to, okay, we're not doing that. AI, let's exit. So what are we going to do? First, we need React. This is important, of course. We need a server renderer, and React exports one. This is not the best one because it's synchronous and blocking, so you shouldn't ideally use this in production. But for the sake of learning, it helps us understand what's happening. This just takes a tree of virtual DOM and turns it into an HTML string. It takes a big thing of objects, React nested elements, turns it into HTML. That's what render to string does. Okay? We need a server of some sort. If Matteo Colina was here, I would use Fastify, but we're not. I'm used to Express. And we need, finally, to run the server. So we'll instantiate it. And this is, by the way, why Express is weak. It's a singleton. So we'll instantiate it. We'll listen to static directory. So this will help us get CSS and images and things like that. And then we start using the server router. So we'll get on, like, let's say /list. We get the request and the response, and we'll do something. And in this case, we're just going to respond with exactly. So we're going to just render our React app to a string, HTML string, and we just respond with it. And we import our components like so. Okay? These are, again, they're just static imports like this. Finally, we listen on port 3000, and we're good. So we'll save this. And ideally, with this, we should have some type of server render on port 3000. Locally here, I don't know if you can see that, but we're listening on port 5173. So I'm going to kill that. We'll build and then run our server. And so far, so good. And if we go to 3000/list, okay, we have it. We have server rendering. And if we look at the markup, there's actually more content here. It says RSC thingy, it says server time. There's actual markup here that's useful. So we have server rendering. This is great. However, we don't have routing. We only have one route /list. If we want to add more routes, we'd probably do something like this. But of course, this doesn't scale. If you have 500, 1,000 routes, you can't just copy paste routes like this, and frameworks don't do that. What's the alternative? We use the file system. File system based routing. So we look in the pages directory, this one, and we basically say any file in here becomes a route. Just read file with no JS, okay? And that's kind of what we'll do. So how do frameworks, how does Next.js, how does Remix do that? Let's write some code and figure it out. So if we come here, instead of this being deterministic, we'll just turn it into a variable. So this colon means it can be a parameter. It can be anything we want. And now what we can do is using dynamic import, we say component is we await and we import from the current working directory, and we'll go to dist, we'll go to the pages directory here, and we'll get rec.params.page, right? And we'll take the default export from there. And this is why in apps like, in frameworks rather, like Next.js, your page always has to be a default export, because it's a predictable name that is standard compliant. If each of your pages, exported something like this, it's going to be very hard for the framework to predict, okay? So we have a bunch of things in pages here where each one is a default export. We export default. And then we take the default export and make it a component. And now we just render whatever component we import. And just for fun, we can take the query params and use them as props. It's our server. We can do whatever we want, okay? So we've just added file system based routing. Everything in pages now becomes a route. Let's see how this works. So if we rebuild our server and run it, we go to /list, we should have this, we do. And if we go to /detail, breed is Shiba, is it Eba? Okay, yeah, we still have it. You notice it says this one is an especially good boy, okay? So we do have some routing, but you notice there's no data. Why is there no data? There's no data because we're taking the React components and just turning them into HTML. We're not running useEffect where we're fetching. You cannot run useEffect on a server because server effects are very different from client effects. So we're kind of stuck without data. And this is the second piece of the pizza. This is, we need data fetching, and this is what frameworks do for us. And this is where server components fit. Server components fundamentally are, this guy's walking out of my talk. That's fine. So server components fundamentally are data fetching solutions. They are suspense for data fetching. They are basically relay, but not relay. That's the main use case they solve, is data fetching. So how can we solve data fetching with server rendering and server components? Let's take a look. So if we go to our list component, instead of all this useEffect nonsense, what we can do is, first of all, we'll turn it into an async component. It can be async because it executes on the server. That's what server components are. They're components that run only on the server and never on the client. They run on the server, they output a big JavaScript object, that's React Virtual DOM, and they send that over the network to be consumed by React. Okay? So that's what we're doing. So we turn this into a server component by making it async, and now we can do something really beautiful, and this is the elegance of server components, really. Look at this. We can just, oh my goodness, amazing. And we can, instead of all the set state stuff, we can just take all this code and just, remove it. Oh my goodness. We can remove this. And probably the best part is, watch. Oof. Okay? So, beautiful. And this component, we can even include like authorization headers and things here because this is only on our server. It's an environment we control. You inspect your network tab, you'll never see my API token. Okay, so brilliant. Let's do the same thing with the detail page. We can also, by the way, do like SQL queries from here. The server components are just very, very powerful. So once again, we'll just async await. We don't need all this useEffect mumbo jumbo. We don't need set image URL, and look at, oh, fantastic. Just one thing, with server components, you can never use hooks in them. Hooks are inherently clientful, okay? Which is even better if you ask me. So we have some issues because TypeScript now thinks we're doing something weird. React elements are supposed to be JSX elements. These are promises of elements because they're async. So we just fix it like we fix all the TypeScript errors. Yeah, thanks. Okay, let's rebuild our server, and let's run it. And oh no, everything broke. What's going on here? And this is the problem. So we throw an error because objects are not valid as a React child. And what did we find? We found object. Something's really not right here. And in fact, here, this is the error. We found object promise. So React is like, on the server side, React is like, I need to render to string, but you give me a promise. What am I supposed to do with this promise? React cannot render promises. How do we solve this? We solve this using a React server components server renderer. Oh, what is that? So there's a server renderer that takes a tree of elements and outputs HTML, but in front of that server, we need another server that takes a tree of server components and unwraps all the promises, just like awaits everything. Okay? Then you get this big JSX tree that has all the data dependencies resolved. Everything is awaited. You pass that to render to string. That then becomes an HTML string and goes to the client. So we just need a way to await everything, to turn all the promises into React elements, okay, recursively. So we can do that by writing a function that does that. So if we go to our server, we need so we have render to string and we pass our layout. What we really need is unwrapped RSCs, and we call a function await unwrap RSCs, and we pass this in. And then we take the unwrapped RSCs and we give them to render to string. This is what we need fundamentally. Okay? But what is this function? Well, we need to write that function. And what we need to do is go through every possible type of React element and await it, basically. So it's not very difficult, we just need to write it. So unwrap RSCs is an async function, takes some JSX and does stuff to it. By the way, JSX, just so we're all clear, becomes something like this. Type is div, props has children like this. This is every React element ever. And every React element really is just a big tree of these recursively. So this, right? But in our case now, div is not always a built-in element. It can be a function component. That's this. This is valid as a React function component. That's actually what layout is, right? It's this, and it returns. It returns either a string or it can return another React element. It can return a number of things. But with server components, this gets even more complex, where instead of just a function component, you can have an async function component. Whoa. And so we need to handle all these cases, okay? So that's what we're going to do. So first of all, notice children can be a React element, or children can even just be hello. This is valid. Children can be a number. Children can be Boolean. And all of that is just valid React elements. So scalar values are valid React elements. So let's handle that first. If, let's say string number Boolean is type of JSX, or JSX, right? Then we just return it, because these are all valid React elements. We don't even need to await them, because a string can never really be async. It's a string, okay? Second, if it's an array, often you use this, like React fragments, which are just arrays. We await, just recursively calling this function over that array, okay? The real secret sauce is if they're objects. And so if type of, oh my God, I'll just write this myself. I trust myself more. If first of all, if it's an object, we need to do something. As we know, all valid React elements are objects, but not all objects are valid React elements. There's a special way for React to know this object is a React element. And that is one property on the object called $typeof, okay? So we check that specifically. If JSX.$typeof equals a symbol for, this is how React knows this is not just any object, but specially a React element, okay? So now, if it's a React element, we can have two types of React elements: function components, built-in components. So we need to handle both those cases. If type of JSX.type is a string, then it's a built-in component. It's a div, it's a span, something like that, okay? If it's a function, it's a custom component or a function component. We need to handle that case. Finally, if it's not a React element, but JSX is just an object, it's probably props. Props can also be async. We need to await the props. So in the branch of the if, where it's not an element, so that's like here, we have to handle the props case. So we handle these cases, await everything in our React tree, pass it to render to string, and then we get server rendered server components. Okay? So let's just handle this really quickly. So if it's a string, what do? We return. We don't actually change anything in the element, but the props. The props become a recursively awaited set of props. We just go unwrap RSCs, and we say JSX.props. And then we recursively call the function on the props. We'll end up here, and then we can process the props, okay? If it's a function component, React function components return JSX when you call them, and you call them with their props, right? So that's what we need to do. So we need to say const returned JSX, and we just do something like we call the type with props. This is how every React component works. You call your function, you get back some JSX with props, okay? Spoiler alert. But our functions can be async, so this is really important. Also, our props can be async, so this is really important. Unwrap RSCs. Oof. So we just like await everything. Finally, we return the unwrapped version of whatever JSX we get out of the function component. We just go through the tree and unwrap it. We're just awaiting at every level in the React tree. That's all we're doing, okay? Finally, we'll handle the props case. So we'll return. And what we need is, we need to map over the props. So we'll map over JSX. And what we'll do is, when we map over an entries version of the props, we get the key, we get the value of the props object. We do this. Exactly. Thank you, Copilot. We just have to unwrap the value of each prop, because the prop can be async. It can be a child, that's an async function. So we just like await everything. But now, since it's an array, if we have an async callback, then we get back an array of promises. So what we need to do is await promise.all of this. Finally, we want back a props object. We don't want entries. So we'll return object.fromEntries of promise.all of object.entries with an async map. Somewhat unreadable. I hope you're able to follow it. Again, what we're really doing is just awaiting everything. Okay? Finally, we get this awaited unwrap RSCs. We pass it to render to string, and ideally we have HTML now with data dependencies resolved. Let's try. So we'll go back here. We'll start the dev server. So far, so good. And now if we reload, great. So this, it's important to this is not using React at all. This is all straight from the server, just HTML, with markup, with the list of reads. It's all fetched on the server. The magic of server components. And if we click here and navigate to Callie, perfect. We can navigate. This is using the platform 100%. This is not using React at all. The beauty is if we inspect it, what we can see is there's just markup. And it's static markup. So if we go to the server side, we have a list of different dog breeds, Bazanji, Beagle, etc. So it's fully search engine indexable, and it's also server rendered, but data is fetched from the server and sent. This is tremendous. This is the value of server components. If we look at the output of the server components before we get HTML, this is really interesting. So before we send the string, what we send is the unwrapped RSC's output. Let's see what this looks like. So if we kill the server, restart it. Come on. What? Invalid. That's maybe res.json. Because it's a big JavaScript object. Okay, well, we don't need that. I'll show you that in a second. So now we have this HTML. The data fetching is working. But because now we are server rendering server components, we can pick that up on the client side and do some magic. For example, this is a great app, but I lose my state. If I enter my name here, and if I navigate, because it's just using the platform, it's not using React on the client side at all, I completely lose my interactivity when I navigate. Why is this taking so long? Is the internet? Okay, yeah. Whoa. Connect time. Fetch failed. Okay, well, the internet didn't work. By the way, we're using Undici to fetch. That's also from Matteo Colina. Great project. Is the internet working? Let's try. So let's go back here. Can some? Okay, so it's totally working. So now I enter my name, and I go back, and you see I lose the state. It just goes away. That kind of sucks. Also, if let's say let's make our server a little bit more fun, right? If the rec.params.page is list, then we'll show a white background. But if it's the detail page, we show a black background. How about that? Let's try this again. So now ideally we see a black background if the internet works. Okay, and then when I navigate, it's white. But this is so like, yuck, it's so harsh. Because we control the JSX output from the server, we can pick it up on the client side and create soft navigation, where we preserve state between page navigation. And this is the beauty of server components. It unlocks all of these things. So let's look at how we do that. To start with, remember when we started this talk, this was the client-side app. We're still doing that, but we're not using React on the client side. Let's add React on the client side to see what happens. We'll do that by coming to our server, and when we send the HTML markup, which is here, instead of just sending HTML, we'll send HTML, and then we'll include the client bundle. So we'll say source is client.js. And now we have React on the client side. That's that simple, right? And let's rerun our server, and what we see is everything goes away. Because we do have React on the client side, but React is doing some reconciliation, and it's like, wait, I have a set of components on the client side. You're sending me these things from the server side. They don't match. Panic. Right? So we need to take the JSX tree from the server side and give the same tree to React on the client side. That's the magic. How do we do that? We attach it to the window object. So script, and we'll do window.initial.jsx, and we'll just like json.stringify our server component output from here. So we have unwrapped RSCs. We'll just json.stringify unwrapped RSCs. The problem is everything here needs to be serializable. Functions are not serializable. Okay? Symbols are not serializable. And if you remember, symbols are how we know that some object is a React element. So how can we serialize the symbol? We serialize the symbol using an escaper. So json.stringify has a second argument, and it looks like this. So we'll say const serialize, and this function gets two arguments, key, value. And so what we can do here is we can say if the value is a symbol for a React element, then we return a new value, which is just a string. And this you can serialize. So now type of, $, type of, right, will be a string. It will not be a symbol when we serialize it, okay? And for any other value, just return the value. Return value, okay? We don't need this key. So now we pass this to json.stringify, just like that. Let's quickly take a look at what happens when we do that. So we'll run our server. Again, this is not going to work, that's fine. But if we view the source, window.initialJSX, type of, this is normally a symbol, but we changed it so we can send it over the network. And this is just a big React tree. So we have HTML, props, children, has head. It's just a big tree of HTML. In fact, we can maybe make this nicer if we do new lines, so you can see exactly what we're sending in initial.jsx. So let's reload this. Yeah. So this whole thing is just our page, RSC thingy, and you can, at some point, you'll just see a bunch of dog breeds. So like Baz and G. These are, each one represents a list item, an LI. So we send this, the client over window. We need to pick this up on the client side and use it to render on the client side. Okay. So how can we do that? Well, now we have window.initialJSX. Let's go to the client side, and instead of this, we just do this, window.initialJSX. Is it all caps? It is all caps. This can work in theory, but this will not work because the symbol is not there. Type of is $RE, right? Type of is this. We need to turn it into a symbol. So we need to do the reverse of our serialize. So we can do that. We just copy this function, same function, to the client side. And instead of serialize, we'll say deserialize. And if the value is RE, we just return this. So we're just doing the opposite on the client side. Okay? And now we json.parse this with the deserialize function. But this is not a stringified JSON object. Look at it. It's an actual JSON object. So we need to stringify it on the client side, and then we parse it. So this looks a bit complicated, but we're doing this for good reasons. Oh, and finally, initial.jsx doesn't exist on window according to TypeScript. So once again, great. And now we should have React on the client side, and it should actually work. So let's go localhost 3000/list. Perfect. And we are using React on the client side. While this is great, we have React on both sides, we still haven't solved the problem of soft navigation and state. So if I enter some state and I click on this, I still lose it, and the transition sucks. It's not smooth. But now that we have React on both sides, we can fix it. And this is the end. We'll wrap up here. What can we do? Well, what we can do is we can listen for click events on anchor links. And instead of navigating, we can prevent default. We can fetch a new tree, a new React tree from the server, just a JSON object, and tell React, hey, React, re-render the whole page with the new tree of elements. In theory, this re-render should be smoother than a whole navigation. Let's execute that. So to start with, what we'll do is we'll add an event listener to window on click, okay? And we'll say if the event target's tag name is not an anchor link, we don't do anything. We're only interested in link clicks. We'll prevent the default behavior, and we'll navigate to e.target.href. Now, navigate doesn't exist, and also the types for these things are really complicated, so this is not a TypeScript talk. We need to implement our navigate function. Let's just first confirm that everything works. So we'll do navigate is a function that says hi. Okay, this is a lesson in debugging for you. Okay, so save this, and does it work? It does not work. It does not work for multiple reasons. Let's take a look. Let's go to the server. What are we doing here? So we're loading the client before passing the initial JSX. We should maybe flip this order there. Let's do this again. Come back here, reload. And now when we click on a link, so we prevent the click and we say hi. This is great. Next step is we fetch the next page as React elements, give it to React on the client side and say re-render, okay? How do we do that? We'll say next page JSX, await, fetch. We'll say we're fetching the next page. So next page. But we'll add a route param, and we'll say JSX is true. This says, I don't want an HTML string, I just want JSX for the next page. And then we'll take that JSX and give it to React. So when we get the JSX, we'll serialize it to text, and then we'll deserialize it. So exactly. So we'll take the text and we'll call our deserialize function to replace all this RE with symbols. Okay? And now we have the next page JSX. What do we do with it? Well, we call root.render next page JSX. So remember here we hydrate the document with the first tree. We get back a root. We just re-render the document with the next page. That's it. The final piece is on the server side to not return an HTML string, but to return this thing. So we'll do if rec.query.jsx. We'll return early, and we'll send the stringified version of unwrapped RCs. We don't need this. Okay, so we're just sending a string and picking it up on the client side. If this isn't clear, this will become clear in just a second. So we'll build, and now we'll reload. And now if I enter some state, your name is Orejuela. So I'll enter your name here, and if I click on blue tick, perfect. The state is persisted and the navigation is smooth, because React on the client side is not actually navigating, but it's saying, hey, give me the JSX for the next page and I'll render. And this is the beauty of server and client components. And if we look at the network tab, for example, just to make this more real for you, what we're doing on navigation is we click on like chow, and if we look at the fetch, what did we fetch? We fetched this. Let me just bump the font size. We fetched a tree of React elements, right? It's just a big tree of React elements. Background color prop is black. And we pass that to React on the client side, and we'll just re-render. So we persist state between navigations. It's beautiful, soft navigation. And the best part is we use the platform. So if we disable JavaScript in the beginning of the talk, right? If we disable JavaScript now, we still have a full page that you can navigate. Everything works. The only drawback is the background color doesn't fade, and you do lose state between navigation. But still, everything kind of works, and it definitely works better than the client only. And so this is the benefit of React Server Components. This is how it fits, and this is why there's such a big push for it. I hope you're able to understand now React Server Components and the use cases they enable. We covered a lot of things today, right? We covered server-side rendering. We covered server data fetching, server components. We covered initial JSX through the window. We covered soft navigation. I hope it's given you useful information that you can take with you and use as you understand JSX. He's nodding, so I feel validated. Great. There's a longer version of this on my YouTube channel. I would recommend, if you're interested, to go take a look and learn there. I don't care if you subscribe or hit the bell or not. I do it just for fun because I enjoy it. And also, I'm writing a book on React with a lot of details about internals and things like this. It's not how to use React. I think you already know that. It's how React works. And so if you're interested in that, I'd recommend having a look there as well. But for now, thank you so much for having me. It's been an absolute pleasure.
Thank you. Thank you, Tejas.
Thank you, thank you.
Any questions? Yeah.
Yes.
Hi, just one quick question. From moving from the first implementation to the second one, by doing so, are we losing on the search engine side?
The first implement, you mean from client only to?
Yeah, from returning directly an HTML document with templates and stuff, from just turning a React element, which then gets injected on the client side.
We're not, because search engines typically don't understand JavaScript specifically with page navigation. But just now what I did was I disabled JavaScript and showed you how when you click a link, you still go to the next page. The only thing you lose, and the way search engines see it, is you don't persist state between navigation, which for search engines, they're not stateful anyway, so it doesn't matter. They just go to pages, index them, and move on.
Okay, so we still have some content in HTML doc. In the
you have all the
state.
content, correct?
Okay.
Yes.
Okay, thanks.
Yeah, no problem.
Someone else?
Hi. Do you know any use case in which this approach have drawbacks, disadvantages, or is not suitable?
Actually, this will be controversial, but no. I think React Server Components is revolutionary in a very good way, because a lot of what people have said in the past is you can't have big dashboard interactive style like Google Analytics. To do this with React components, React Server Components would be absurd, is what people would say. I don't think that's true, because ultimately you're separating really nicely the concerns of data and interactivity. And so with Server Components, even for like heavily interactive applications, if you have a dashboard, say, that needs to fetch and then render 1 million data points, you can do that on the server and keep all the data fetching close to your server. And then you send the output of that in terms of JSX, right? So it has benefits for every application. I think the biggest drawback here, there's one, and that is if you have an existing React code base before Server Components, that re-architecture can be a massive pain. Because you go from something being previously literally serverless, and I mean that correctly, serverless, to being server full. And also you need to rethink a lot of React problems is components mixing concerns. This is, again, product code, not React's fault, but a lot of us, I do this, I used to do this more, right? Is I'd have a big chunk of markup with a title, if it's a blog post, title, content, and a comment form with inputs and a submit button all in the same file. Many of us do that. I don't think that's unique. And the problem here is a tiny portion of that, the comment form, is interactive, but a lot of it is not. And Server Components makes you think more about, is this interactive? Should this be a separate module than we did previously? And the drawback is if you're migrating to this, you probably will have to like rip out many components and make new files and move things around, which will then result in a very large pull request. And your team would be like, why did you do this to us? And it's going to be difficult to review. So the migration to Server Components is the drawback, is the only drawback as far as I can see. Julia's getting some cardio today.
Hi, great talk.
Thank you.
In the past, a big push to adopting the first frameworks and libraries was to take advantage of the client computational power. And how do you think server components fit in a context where the server computational power is critical?
Yeah, I mean, I haven't heard of any cases where the client computational power is like supersedes the server computational power, right? Because it's such an alien environment. You have no idea about your client's computational power at all. I build a website and someone in Germany, but like with a Samsung Galaxy 2 uses it, and I'm like, oh, I didn't think about this. And so the server context is just way more predictable. It's my server. I control it. I could give you 16 gigabytes of RAM. And that's why I think server components are so compelling, right? They remove some of that ambiguity from the way we develop software. We don't have to always think about, is this going to give you performance problems on like low power devices? Because for server components, we control the power of the device. So, yeah. I'm not sure if I answered your question. Okay, great, no problem.
Good. So, with perfect timing, if there's no more questions, okay.
Great.
So, thank you, Tejas, as speaker, and now please welcome Tejas as MC.